Chapter 11, Example 1. First, let's talk briefly about parameters versus a statistic. Mainly, it's a notation thing we need to pay attention to, but also the meaning behind it. A parameter is what we think is like the true value, if we know the true mean of something. If we know 65% of all Americans get 8 hours of sleep a night, that would be a parameter. We'd only know that from finding every American and finding out how much sleep they get, which is something we generally never know. Most of the times you're not going to know a parameter. A statistic is something we get from data. So we survey 1,000 Americans and track the amount of sleep they get. Then we can say from our sample the average amount of sleep is 8 hours. That is a statistic. We gather it from actual data. That's not a census. It's not everyone. Parameters if we know the true value, which almost never happens. Now, parameter wise, for means, the parameter is mu, and the statistic is x bar. And that's the difference, just the notation generally that's used. If you see something say mu equals, then you know it's a parameter. It's for a model generally. It's like what we think the true value is. And x bar would be the actual statistic. For standard deviation, generally we're going to use sigma and s for the standard deviation. Okay, so we start to see some trends. There's some other ones we'll get as the year goes on, but those are the means we work with so far. And that's the main difference. That's why with our normal model we see sigma and mu in there. Those are from theoretically what it should be if it was a true value from our model. What we'd have x bar and s are the actual information we get from data. It's important to understand that it's what we would get from running an experiment. Okay, so now let's look at example 1. You've decided to conduct a survey at Eastern High School. How could you obtain an SRS? Now these questions, I'm going to go ahead and put answers up here, but I recommend before you see the answer, just pause the video and think a second. How would you do an SRS? How would you do a stratified sample? Think about it before I go over the solution. It will mean more in the long run. So obtaining an SRS. This is a simple random sample, which means every outcome is equally likely. It has an equally likely chance of occurring. So any groups in there, everybody in each group would have an equally likely chance of being picked from any group. So we're going to number all students in the school from 1 to whatever. If there's 2,000 kids in the school, we number them 1 to 2,000. Okay, then we'll randomly select students using a random number table, using generating random numbers with technology, until you have an appropriate sample size. So maybe we need to sample, we think there's 1,000, there's 2,000 students at Eastern, we want to sample 100 to get a good idea. So we would number every kid 1 through 2,000, we would randomly select 100 people. If we get a repeated number, we just ignore it and get another number. And then those are the people that we would survey. Okay. A stratified sample. This is where we break it down by strata. We think there's different groups in our data. Maybe the question we're asking could differ by gender or socioeconomic level. Maybe we think seniors are going to answer differently than juniors, so we want to break it into these different groups. So we group students by some commonality. Let's say in this case we want to know average height of students at Eastern. So we think, okay, girls and boys have different heights on average, so we're going to stratify with sex being the strata. So I would group each person by their sex, and then I would randomly select from each one. We're not picking everyone there. So let's say about 50% of the population is women, 50% men. So out of our 2,000, we'd expect about 1,000 boys and 1,000 girls. So we'll have one group of 1,000 girls, we'll separate into a group of 1,000 boys, and then we'll randomly select maybe 50 from each of those strata. Okay. Cluster sample. Now, cluster goes by the idea that we have a representative group, so we can look at a bunch of different representative groups. One group that might be the same from class to class at Eastern would be advisories, maybe. Now, if you're in an advanced class, then there might be something different for people in a honors class, or an English class might have a different makeup of students than in art class. For some reason, maybe people in an art class are more likely to have a different answer than somebody in a technology class. I don't know. So advisory would be a good thing to sample from. So a cluster example would be choose an advisory class. Probably better to pick a few. So pick maybe like 5 advisory classes at random. We would assign every advisory a number, randomly select it from generating it with a table or technology, and then we would survey everyone in that cluster. That's very important. Anytime you're answering this, if you're doing a cluster sample, make sure you state that you will sample everyone in the cluster. That's what you need for an appropriate cluster sample. Okay, so for a systematic, kind of jumped the gun there, but for systematic, you're going to survey every 8th person. We're having a system in place, so we're selecting the same person from each one that enters the cafeteria. We'll begin by selecting a random person, though, so we have to have randomness in there. I'm going to generate a number 1 through 8, and let's say I get 5. So I'm going to look in the cafeteria, the 5th person that comes in, that's who I'm going to select and survey first. Then every 8th person after that, I will select and survey. That would be systematic. It's not necessarily as good as an SRS, but we get good information. It has randomness involved, and that's the key. You always want to have randomness in any sort of experimental design.